Our next speaker is Reese Jones. Reese is a biophysics Facebook advisor and an associate founder of Singularity University in Silicon Valley. Based in San Francisco, Reese has helped launch multiple companies, innovations, and patents. He likes building infrastructure company for emerging technologies in AI, blockchain, health, biology, mobile, and internet. Let's welcome Reese.
Thank you. Good afternoon. We're going to talk a little bit how lessons learned from biology can give insight into blockchains. And that biology has been evolving for 4 billion years and blockchains for a decade or two, as we'll talk about. And some of the things that have changed in biology are likely to change in the future for blockchains in new forms that have yet to evolve, like new species. And so the basic things that blockchain brings to the internet that didn't exist before is as a way that I can send you something that can be trusted and is documented. And by being able to do that, it's a way that we can exchange money, which is important that you trust the exchange of the money. And then when I do that with you, it's something that we agree upon at the time is a true transaction. And if we're on a public blockchain, this is recorded as the truth, at least contemporaneous with the parties involved as to what happened. And then it's saved in a permanent way that even if you change your mind later and change the transaction later, the first transaction is still recorded on the blockchain and stays there indefinitely and can't be changed. And so in accounting of money, many of you are probably familiar with double entry accounting, where it's something that evolved around 500 years ago, and is something that where the debits and credits of money, like how much is coming into me and how much is going out from me, are recorded as two separate things. And if the totals of the two don't equal at the end of the day, then probably there's a mistake that needs to be looked into. And so this is a reliable way of keeping track of money over time. And what blockchain brings to this is a sense of triple entry accounting, where I can keep track of the money in and out, you can keep track of the money in and out, and then we both agree to write that to the public ledger or a private ledger that is unchangeable. So we have an extra level of security as far as what happened to the money over time. And this record is, we agree, is the truth about our transactions. And in the case of a decentralized blockchain, it's distributed in that it's across thousands of computers. And so not only can the blockchain not be changed mathematically, the fact that it's stored on thousands of computers means even if you were able to break the cryptography, you could change it on one of the computers, but getting them to update across all the others is another level of problem. And so there are things that predate Bitcoin and blockchain that use a similar kind of distributed cryptography technique. There's a company, Surety, that runs a blockchain, digital signatures of data that has been transacted between people. And they take all of that, summarize it into a hash, and then every week they publish in the Lost and Found section of the New York Times the hashtag. And so if anybody tries to change something, it would change the hashtag. And the hashtag has been printed in hundreds of thousands of papers. And so even if you were to try and collect some of those papers, change it, and fake it, there would be out in the wild other examples of the truth. And so this is a way to do these transactions in a public way. And so the inventors of this are actually 3 of the 8 publications that Satoshi published in his white paper 10 years ago. And so it's a fundamental predecessor to blockchain and Bitcoin. And then other tools are evolving that Elliptic, for example, traces through blockchains over time in history to evaluate, say, the money in and the money out. And so these kind of tools are evolving for this new world of distributed triple entry accounting and ledgers and so forth. And the information that flows through this system is strikingly similar to that of genetics and DNA and biology. And the human genome, like me, is about 1.5 gigabytes on a computer, or 3 billion letters, base pairs of DNA that holds the information that grows into me. And the current blockchain of Bitcoin is already 150 gigabytes, so substantially more than the amount of information in a human genome, and growing at an exponential pace. And that's because computers can replicate data structures like a blockchain more accurately than biology can replicate DNA, which has an error about 1 in a billion base pair in each copy. And so the potential for blockchain to grow is substantial because of the improved copying capability of computers, which is not perfect, by the way. And blockchains get harder or easier depending on how long it took to record the last block. And it's set up to record a block every 10 minutes, and has been for the 10 years it's been running. And it resaves every transaction since the Genesis block in every new transaction. And if the block writing happens faster than 10 minutes, the algorithms get harder. If it is slower than 10 minutes, they get easier. So you can predict over the next 100 years how long it's going to take each block to be written, 10 minutes, and the size of the data that that's going to be using. And the graph here on the right is the forecast size of Bitcoin's blockchain over the next 100 years. And so the interesting thing about blockchain that is often talked about is that it's a decentralized system. It's distributed through thousands of computers. It's borderless without regard to country borders or other kinds of borders. It's a self-replicating system in that the whole block, or the whole chain of information, is replicated with each block. And it's an information framework for how information is stored and moves. And then it's a protocol for how this is done as well. And so the thing that struck me that's remarkably similar is genetics, in that there isn't a centralized bank of genetics. There's not a centralized government of genetics. It's a borderless system for animals and creatures, and it's a self-replicating system, and it's a framework for how information is stored over time, and a protocol for how that metabolizes within a species and replicates between species or individuals. And so to replicate this information, in Bitcoin, you use mining to calculate whether or not the next block should be written by you or somebody else. And in biology, the energy that comes to do this happens from predation, in that you have to either eat food to have the energy to replicate, or photosynthesis. But in either case, you're consuming energy to process the information. And the graph in the middle is the amount of compute power to replicate a blockchain block that's required. And the compute power requires electricity in the proof of work algorithm that Bitcoin works on. And there are other algorithms that are being proposed and already out there that are more efficient compute-wise, but maybe have other downsides like risks. And so there are essentially other species of blockchain from the Bitcoin species, and it's something that natural selection will decide which ones survive and which ones don't. And so in biology, if you were to step on a petri dish with your shoe, very quickly the petri dish would grow a whole diversity of creatures, many different kinds that are all DNA-based, but they have different characteristics. And so I would suggest that blockchain is going the same way, in that if you look at the ecosystems of blockchains, there are actually many different, a couple thousand different blockchains that have all emerged in the last couple of years and continue to be diversifying and growing. So these are essentially different species of blockchains where Bitcoin and Ethereum are two different species, but Bitcoin Cash is a third different species and so forth. And whether they succeed or not is based on their fitness for the ecosystem. And so information flows through biology in the form of metabolism, and information flows through tokens in these metabolism of tokens. So a Bitcoin token is metabolized on the Bitcoin blockchain, and its fate is determined by distributed apps that can be constructed into distributed organizations. And whether or not a particular kind of blockchain, a particular species of blockchain survives, again, depends on the environment that it's in, where something that is slow and expensive to transact may be poorly fit for doing parking meter payments, but better fit for real estate transactions, for example. But something that's fast might be less secure. And so the natural selection will decide which survive or not. And the blockchains could go in either two directions, either a single standard like TCP/IP in the internet, or a diversity of standards like the millions of apps or the millions of websites that are out there. And it seems it's going towards the latter, towards millions of different blockchains instead of one standard blockchain. And that's a good thing, because if there's one standard, a bug in it or some kind of regulatory problem, it's brittle, it's fragile, in that if something were wrong with Bitcoin's blockchain and wiped out Bitcoin completely, Ethereum's network wouldn't necessarily be affected, and vice versa. And so it's something, this diversity is a good thing for the stability of cryptocurrencies in general. And one of the natural factors that is affecting this ecosystem is government regulation, in that the definition of what is security, what's a commodity or currency, or what's a utility, is being decided by different governments in real time. And so which ones survive or not, which blockchains and tokens survive or not, will be partly dependent on this kind of ecosystem change as well as their usefulness. And so the diversity of blockchains is likely to further diversify, just like plants and animals. And in biology, over 4 billion years, the different kinds of creatures have evolved into many. And so this is a graph of all the current living creatures on Earth and kind of their heritage. And everybody is cousins from each other in that we all use the same DNA. And there's been all of these forkings of different species over billions of years to create the world we find ourselves in. And so blockchain is another extension to this same complexity of evolution. And so what happened in evolution about 500 million years ago was the Cambrian explosion, where a few species of organisms turned into 3.5 million very rapidly. And this happened around the same time as eyes and brains were invented by biology, where sort of the smarts of biology, similar to adding AI and sensors onto blockchains, where they can see each other and become predators and prey and so forth. And so this is likely to happen with blockchain, but hasn't been invented yet. And then in the further future, the information that defines me, or a biological creature in general, is becoming increasingly digital, where there's still the DNA in me and the food that I've eaten for my whole life that makes up the DNA information that's in me. But more and more, the definition of me is stored in my medical records, my credit report, and my Facebook posts, and all kinds of information that is stored in digital form that defines a person increasingly more than their genetics. And so we are becoming information, and that information is something that changes over time. So the changing information is more like being on a wave of the information changing underneath us. Our molecules change, our Facebook posts change. And so our life is actually surfing on this information as opposed to being a static form of information. And so in these ways, blockchains are like biology. It's not a perfect match, but it's very similar. And there you have it. Thanks.